Hey guys, I'm back. Lesson 7, Empirical Formulas. This is on page 21 of your notes. Our objectives for this lesson will include explaining what an empirical formula is and learn how to determine empirical formulas from given chemical formulas. And in addition, you will determine empirical formulas from percent masses. Let's start with our warm-up. And what I'd like you to do is review your notes from previous lessons and create 2 questions from any lessons 1 through 6 to be used as warm-up questions in class. I'd like you to post them on Schoology if you can. If you have not registered for Schoology yet, please do so now. I will be making calls home this week to ensure that everyone is on the same page. I will randomly be putting questions on there and updates for you guys to answer from here on out. So I'd like you to respond to those if possible, like a Facebook type thing, so it should be interesting. Okay, so let's start. Determining empirical formulas. The empirical formula is a reduced formula. It's a formula whose subscripts cannot be reduced any further, basically by dividing out by a common factor. Okay, molecular formula is the actual formula for a compound. Subscripts represent the actual quantity of atoms present. So let's look at a couple here. The molecular formula N2O4. Well, if we look at our subscripts 2 and 4, they can actually be reduced. We can actually divide this whole thing by 2 to get an empirical formula of NO2. Okay, let's look at the next one, C3H9. So we look at our subscripts, and 3 and 9, okay, can be divided out by 3, so that's what we will do to reduce it. It's just like reducing fractions, basically. So this would be CH3. The next one, C6H12O6. So I'm looking at 6, 12, and 6. Again, common factor 6. Okay, so we can divide this whole thing out by 6 to get CH2O. And then we have B410, 4, and 10, okay, have a common factor of 2, so we can divide them by 2 to get B2H5. And the last one here, we have 5 and 12. Well, can we do anything about this? Do we have a common factor? Can we divide this out? No, we cannot. It is in its simplest form, so it will remain C5H12. Okay, so let's do some practice. Determining the empirical formula from the molecular formula. Very simple. So what we're going to do is we're just going to look at the subscripts for each one and see if we can reduce it. Well, we have CH. Basically, the subscripts are a 1 and a 1. We can't do anything here, so there's nothing to do. That is the empirical formula. B, CH3. Again, simplest formula, nothing to do. C3H8. Can't divide that out, so that is already empirical formula. Iron carbonate. Okay, FeCO3, so we have 1 iron and 3 CO3s. 1 and 3, this is in its simplest form, so we're not going to do that. CH2O, again, if we pretend that there's subscripts here, if you have a 1 on anything, it's already going to be in its simplest form. You can't really do much more. So we will move on. Okay, so basically these are already empirical formulas. NH3, again, empirical formula. CaBr2, we can't reduce this, so we will say empirical formula. C2H6, good. Finally found one. We can divide this out by 2 and get CH3. Jing, jing, okay. Na2SO4, remember SO4 is a polyatomic ion, so we would say there's only one of those, cannot be reduced. 6, 5, and technically there's a 1 there, so no, we can't do anything with this. P2O5, 2 and 5 do not have a common multiple or a common factor, so we can't do anything there. These are already in the reduced forms. Radium chloride, okay, again, 1 and 3, no. Selenium oxide, 1 and 3, already reduced. Lithium chloride, 1 and 1, already reduced. So out of all of these, actually, they're all are empirical formulas except for this one, the C2H6. Okay, so let's practice calculating empirical formula from percent mass. Now there are a couple steps here, and it gets a little tricky at times, so you got to read what they're asking you in the question. Step one, we're going to always assume that you have 100 grams of a sample. The total percent for the compound must equal 100, so we're just going to change the units from a percent to grams. Very simple. And then what we're going to do is we're going to use our mole conversion equation to convert grams to moles. So remember, number of moles is equal to grams over GFM. Okay, that's on table T. You do not have to memorize this. Okay, guys? Then what we're going to do is divide all mole numbers by the smallest mole number that we get in our calculation. So here's an example. A compound is 46.2% mass carbon and 53.8% of mass of nitrogen. What is its empirical formula? So step one, assume that we have 100 grams. So simply convert the percentages to the grams. So 46.2% becomes 46.2 grams of carbon. 53.8% of nitrogen becomes 53.8 grams of nitrogen. Step two, then we have to convert our grams to moles. And again, so we have grams, okay? We have grams, and we're going to convert it to moles. How many moles of each species do we have? So for carbon, we are given 46.2 grams. The gram formula mass, okay, it's grams per mole of carbon, is 12.011. Okay, so what we simply do is just divide 46.2 by 12.011 and we get 3.85 moles. Next thing, we're given 53.8 grams of nitrogen. In 1 mole of nitrogen, okay, we have how many grams? Okay, so notice moles per gram or grams per mole in the unit. So how many grams in 1 mole of nitrogen do we have? So you got to look up the atomic mass, which is 14.0067. Divide that out. Our calculators show 3.84 moles. But we must have whole numbers for subscripts in order to figure out that empirical formula. So the subscripts actually are going to be the number of moles. Okay, we can't make our number of moles 3.85 as a subscript. Okay, subscripts are whole numbers. So step 3 is divide each mole number by the smallest mole number that we have in our calculations. So we will round in this step to the nearest integer if it's super close. Okay, integer meaning one single number. All right, so the smallest number of moles we have is 3.84 out of the 2 that we calculated. Okay, so going back up here, we have 3.85 or 3.84. We're going to go with the lowest number. So when we divide this out, we get 1.0026, okay, which is then going to be 1. It's super close. And then for nitrogen, 3.84 divided by 3.84 is equal to 1. So this tells us how many moles for each we have. Okay, and these numbers right here, guys, the 1 and the 1 here, will become subscripts on each species. So therefore, the empirical formula is going to be CN, okay, or C1N1, which we don't write the ones. All right, so let's do some practice. Determine empirical formula from the percent composition for each of the following. So number 1 says a compound contains 24 grams of carbon and 32.0 grams of oxygen. Calculate its empirical formula. The hint is to start with step 2. Okay, well, step 1 we can skip because we're not given percentages. We're given grams. So let's go to step 2, and we're going to convert our grams to moles. Okay, so we have for carbon, so we're going to separate this. For carbon, we have 24 grams of carbon. Okay, and we're going to divide that out by the GFM to give us the number of moles. All right, so 24 divided by 12.011 grams per mole in 1 mole of carbon, and we will get what? Approximately, okay, you're going to get like 1.998, but we're going to round that to our sig figs, which gives us 2.00 moles. All right, so for our oxygen, they tell us our mass is 32.0 grams. of oxygen. And our GFM for oxygen is 15.9994 grams per mole of oxygen. Okay, we divide that out, we're going to get 2.00 moles. Now for step 3, it says to divide out by the lowest number of moles. So I'm going to do step 3 here, okay, in this section. So we have 2.0 moles divided by the lowest number, which is the same, so 2.00 equals 1. And then over here, same thing, 2.00 moles of oxygen divided by 2.00 moles lowest number, 1. So these are our subscripts, 1 on the carbon, 1 on the oxygen. So our empirical formula is carbon monoxide. Okay, number 2 says a compound contains 0.50 moles of carbon and 1 mole of hydrogen. Well, we don't need to figure out grams here. We're already at moles. So what we need to do is just basically skip ahead and just start with step 3. So for carbon, they give us the number of moles, 0.50 moles. Okay, it says to divide by the lowest number of moles, which is 0.50 in our problem. Okay, so this will give us 1, a nice whole number. For hydrogen, we have 1 mole divided by the lowest number, which is 0.50 moles, which gives us 2. So the subscript on the hydrogen is going to be 2. The subscript for carbon is 1. Therefore, the empirical formula is CH2. Okay, so as an exit, I want you to do the remaining problems, 3, 4, and 5, and have the answers ready at the beginning of class. So you will need to look back at the steps 1, 2, and 3, and figure out where you're going to start. So remember, for 3, you have percentages, so you're going to start at step 1, okay? For number 4, same thing, you have a percentage, and same thing for number 5. Remember to go in and get your atomic masses for each element and go from there, okay? Good luck, guys.